Hey there everybody, welcome back to the channel. Well, there is a long list awaiting for us to do them, and we have completed two from the past 2 days. So this is the third one. Let's see if the filter is still there. So the third one in the list, a medium level lead code problem, lead code 91. Decode waves. Let's see what the problem statement is. We have intercepted a secret message encoded as a string of number. Okay. The message is decoded via the following mapping. 1 is for capital A, 26 is for capital C. However, while decoding the message, you realize that there are many different ways you can decode the message. Because some codes are contained in other codes. 2 and 5 versus 25, for example, can be decoded into A. Okay. A. Sorry, A. 10 will be like 1110 6 and 1110 6, or 1106 is invalid because 06 is not a valid code, only 6 is valid. Okay, note there will be strings that are impossible to decode. Given a string S containing only digits, written the minimum number of ways to decode it. If the entire string cannot be decoded in any valid way, return 0. Okay, the test given string containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid way, return 0. Okay, well, for example, if we take this, okay, so this cannot be decoded in any way. Let's go. Let's create decode. So the thing is, it is two things. One, we can take one value at a time or two values at a time. The digits will be between will be between there will be one digit or two digits. So let's go. If let's take index equals to I, if I equals to the length of S, zero. Here, if S of I zero is less than S of I is less than before that we have to do another thing, taking two strings at a time. For that, if I plus 1 is less than
嗯
length of S, and 1 is less than length of I, then I plus 1 is less than length of S, and 1 is less than length of I, then I plus 1 is less than length of S, and 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than length of I, then I plus 1 is less than s of I plus s of I plus 1 for this we should have the values greater than 9 and less than 26. Then decode of s of I is less than or equals to 9, it should be greater than 0. And we have to calculate different ways. Let's keep self dot answer equals to 0. Self dot answer plus equals to 1. Decode of 0. Sorry, self 1, 1 and 0. Let's see. 102. Oh, 1, 2. 0, 1, 2, 3. Everything is missing. Let's see. Okay. Oh, voltage is obviously greater than 9 and less than 26. What is this false? And it's okay. Exographically, 9 is always greater, so it will always be false. Then we have to change them to integers. But let's convert them to integers. Now let's see. Great. It is working great. 1, 2, and 1, 2. 22, 6, 2, 26, 2, 6, 2, 2, and 6. 3 ways, and here 0. Great. What about something like 0, 1, 6, 5? Well, this is working well. So let's see the constants. S will be between the length of S will be between 1 and 100. So let's use LRU cache. Well, this is helpful for storing the occurrences of the values, multiple occurrences maybe. So let's see again. Something didn't work out well. I guess LRU caching won't work in this case because the answer is outside and we are updating the value. We have to update in a different way, I guess. Now, instead of doing this shit, let's return one. So let's think of the call stack. Here 2, 26 will return 1. Now here we'll get 1, but we have still 2 and 6 to be done here. So what do we call it? Let's call it temp1. Well, now let's use the LRU cache. Well, DP never seems to never fails to amaze me. I never thought taking answer from outside would not be helpful with DP. So let's try submitting this. If it works fine, let's start discussing the intuition. Well, this worked great, and this approach of DP is usually called as memoization, which is a bottom-up approach. We'll go all the way down, like going down, going down, going down, and finally we'll return the answer. While removing the stack, we'll add up the answer and finally we'll return the answer. And what we are doing here is we are passing the indexes. We have two options here. One is taking one value at a time. So the one digit at a time, we can take 1, 1, 0, and 6. But 0, 6 is not helpful. So we'll do 0, 6 here. If the value is between 9 and 26, we will go for forward. Or if the value is between 0 and 9, 1 and 9, we'll take it forward with one value at a time. Here we'll process two values at a time. And if both of them is not triggered, that means the value is 0 or greater than 26. We'll return 0 for that. And we'll process the remaining values as it is. And by the time we reach the end, it will return 1. So if it returned anything like 1 or anything, we'll add that to temp. And if it returned 1 again, temp1 plus temp2 will return 2, which will be in the temp1 or temp2 letter. And we go forward in that way, and we finally got the answer. Well, explaining DP is one tough thing to do, but I'm hoping you guys understood the intuition. And let's see what others did for the same. Well, this is an alternative approach, which is tabulation. Maybe. Well, it is tabulation. What happens in the tabulation is, instead of doing a LRU cache or maintaining a, what do we call it, a dictionary to record the answers. Here, for example, we don't need LRU cache. Let's take a record dictionary where record of I equals to temp1 plus temp2 and if I record return record of I, it is what we are doing. Now let's submit this. Well, that is what it looks like. So LRU cache is somewhat faster, but not very much difference. 1 to 2 milliseconds, it's not very huge difference. But for huge values like 1000 letters or characters or 10,000 characters, maybe it might differ a bit, but it is still order of n time complexity. And let's see how tabulation working here. And let's try to implement this too, because we have to learn it someday. And why is this day not it is? Let's consider it is the day. So n equals to the length of s, and we created an empty list with all null values and of size n plus 1, and we kept nth value, I mean last value 1. Let's go. We go through for a range of 1 minus 1 comma minus 1 minus 1. Okay, going from backwards. If s of I equals to the 0, then dp of I equals to 0. Okay, continue. If dp of I and dp of I plus 1 is same, sorry, dp of I equals to dp of I plus 1, we take the previous value, and we have to check whether we have to add a value or not. If I plus 1 is less than n and 10 and 26, and it is the value is between 10 and 26, then we are adding the previous value to the previous value to the current value, and finally we are returning dp. And to be frank, I didn't understand why is this how this works. So let's see the explanation. At the ith number is always number of ways to decode starting at I. Yes, not s or s of I equals to the 0 ways to decode. Okay. And another way to decode is, one way to decode s of I plus number of ways to decode. One way to decode s of I plus number of ways to decode s of I. So another way to decode is s of I plus 1 without 26 plus number of ways to decode s of I plus 2. Well, let's try to implement and see. Here n equals to length of s, and we created a dp list, n plus 1, the size is n plus 1, and dp of nth value is 1. I just remembered it, memorized it, but if I have to reproduce it maybe after a 20 or 30 days, maybe I cannot, because I just memorized it for now. Let's see if we learn something from here, then I won't forget it for the life. dp of I equals to dp of I plus 1, we are taking the previous value, and if I plus 1 is less than n and return is less than or equals to dp of I plus equals to dp of I plus 2. And why this will work is we have one value more which is n plus 1 in the dp, so even if we have I plus 1 then I plus 2 will work for sure. And finally we have to return the dp of I, and before that let me see what dp looks like. Sorry. Hmm. So initially kept 1. And 610, okay, 0. It starts with 0, then 0 it is. One sec, guys. I just have written for this, so I'm back. I didn't understand what's happening here. So seems like for every even value we are checking the possibility, and for every odd value, actually we are considering the odd values too. For example, let's think for this one will be big, so we initially kept 1 here, and here it is not 0, so we keep the previous value. We took the previous value for 2, which is 1, which we kept here. Now this became 1. Now for it is less than 26, so for this position this is less than 26, so we took, sorry guys, so we are starting from n-1th position. So this is initially what we have kept. By the time we are at 2, we keep 1, sorry, at 5 we keep 1 here, and at 2 we keep 2 because we take the previous one, which is 1, and we can take these two too. So these can be taken into 2 ways. This is one way, 2 separate values, and this is one way to take both at a time. So 1 plus 2, 1 plus 1, we took 1 here initially, which is one way to do things, and we took plus 1, which is we added the both 2, and by the time we reach 0 we kept 0, and there is only one way to do for 10, so we took 2, and it is only like it will be only one way, so we took 2 here again, because we cannot take one single, 1 and 0 as 2 separate values, we have to take 10 completely. Now we take 2 from the previous, we keep 0 here, and we'll add plus 2, and 6, we take the previous value, which is 2, so until this point there are only 2 ways to arrange things, that is 10, 2 and 5, and 10 and 25. That is what we got here. And we added 1 and 0, and by the time we reach 6 we cannot add 6 and 1, so we take only 6, and by the time you reach 2 we take the 2 forward, and another way to do is we take 26 as a whole, which keep 4, so now we'll have 4 ways to arrange things, that is 2, 6, 10, 2 and 5. 26, sorry, 2, 6, 10 and 25. 26, 10, 2 and 5, 2, sorry, 26, 10 and 45. We are kind of taking, what do we call it, like a branching strategy, where one branch is on the right, we have 2 and 5 separately, and the left we have 25 as the combined value, and 10 cannot be separated like that, so 10 everywhere. So we add 10 to both sides, 25 and this, and we branch out towards the. Now we have two ways to do things: 2, 6 on one side, 26 on the other side, which doubles, so to the power of 2 actually. And by the time we reach 2, we can keep it 2, 2 separately, like from here you can keep 2, 2, 6, 10, 2 and 5, or we can keep 22, 6, 10, 25, and same goes here. So we replace these two with these two. Now we have 1, 2, 3, 4, 5 and 6. So to explain the intuition, we are branching out. So let's take this to subject to make our intuition clear. So So that's it. This is true, but let's give an example free for a field of size 20, sorry, 7. So you'll see how the branching happens. So here is an example 1, 2, 1. See, no, I don't want this. Right, like this. But let's do differently. Use this tree for, we have example, right? This one will work. But not the indexes as nodes, but numbers with comma is separated or without any. If not, okay, though it didn't return the tree as we wish, let's see this as a tree. So we are coming from the back, right? Actually, let's go from the front. 2 can be separated into 2 different ways. 2 comma 2 or 22. So here we take one value or we take two values. Here if we take each value individually, 2, 2, 6, 1, 0 cannot be it, so we won't consider it. 10, 2 comma 5 separately, 2, 10, 2 comma 5 separately, and 2, 5 as collectively. So here we have two leaves, 1, 2. Here we have the third one, fourth one, fifth one, sixth one. Actually, wait a minute. This is not the tree I was expecting, man. double 2 6 10 25 6 10 20, 2 comma 5. So this is, both of these are different. 1 2. Wait a minute, what is the answer here? 6 1 2 double 2 6 10 and 5. It is not different, so we ditch this part. Double 2 6 10 and 25 is already considered, so we don't need to consider these two. So this is where DP comes handy. We don't try these again. So we have two answers. Two as the answer for now. Double 2 26 10 and 25. Third one. Fourth one, we ditch both of these. And finally we have fifth one and sixth one. So I hope you guys understood the intuition. If you like the video, put it and share it with your friends, and don't forget to subscribe to the channel and leave a comment so that we'll get a better reach and I can address your doubts as well. We'll meet you again with another video. Until then, keep learning and keep pushing hard. Goodbye guys, and thank you for choosing the channel. Goodbye.